Hi everyone. So here we're looking at the AP Statistics, and in particular we're going to solve a question from the 2022 free response exam. This is question 3. Okay. So I'll start by reading it out. A machine at a manufacturing company is programmed to fill shampoo bottles such that the amount of shampoo in each bottle is normally distributed with a mean of 0.6 liters and a standard deviation of 0.04 liters. Okay, so already there's some important information we need there. So a machine is filling bottles and the amount of shampoo in each bottle is normally distributed, and it gives you the mean and it gives you the standard deviation. So that will definitely be used later on. Let the random variable A represent the amount of shampoo in liters that's inserted to the bottle by the filling machine. Okay, so the amount of shampoo in each bottle is given by the random variable A. Okay, part A. A bottle is considered to be underfilled if it has less than 0.5 liters of shampoo. Determine the probability that a randomly selected bottle of shampoo will be underfilled and show your work. Okay. So before I solve it, what we're thinking here. So the normal distribution looks like this. Okay, and we know that the distribution is symmetric, so the mean is in the center, 0.6. And the standard deviation is 0.04, so 0.5 is a little more than 2 standard deviations away from the mean, which means it's going to be somewhere down here with a fairly low probability. Okay, and we want the probability that it's underfilled, so that, in other words, that the volume of shampoo is less than this amount here. So we want this shaded area of the normal distribution. Okay, so how do we work that out? Well, the exam paper gives you tables for a standard normal distribution. That's one with a mean of 0 and a standard deviation of 1. So we can solve this just by converting our random variable A into a standard normal and then using the tables at the back of the exam paper. Okay, so what we want is the probability that A, the volume of shampoo, is less than 0.5. So we're going to convert that to a standard normal distribution Z. And how do we do it? Well, you subtract the mean away from the value, so that's 0.5 minus 0.6, and you divide by the standard deviation, that's 0.04. Okay, and then a bit of maths tells you that this is minus 2.5. So we want the probability that a standard normal Z is less than minus 2.5, and as I said, if you go to the exam paper here, this is at the back of the exam paper, you can find tables for exactly this problem and look at this table. So the value of Z is shown in this left hand column here, and we want Z is minus 0.5, which has a probability of 0.0062. Okay. So using the table at the back of the exam paper, then we work out that this probability is 0.0062. So a bottle has a bit less than a 1% chance of being underfilled then, 0.6%. Okay, after the bottles are filled, they are placed in boxes of 10 bottles per box. After the bottles are placed in the boxes, several boxes are placed in a crate for shipping to a beauty supply warehouse. The manufacturing company's contract with the beauty supply warehouse states that one box will be randomly selected from a crate. If 2 or more bottles in the selected box are underfilled, then the entire crate will be rejected and sent back to the manufacturing company. B. The beauty supply warehouse manager is interested in the probability that a crate shipped to the warehouse will be rejected. Assume that the amounts of shampoo in the bottles are independent of each other. 1. Define the random variable of interest for the warehouse manager and state how the random variable is distributed. Okay, so there's a lot of words there, so let's take a couple of minutes to unpack it. Okay, so bottles are filled and they're placed in boxes of 10 bottles per box. Okay, so here's a box, and in each box there will be 10 bottles of shampoo, like this. Okay, there we go. And several boxes, so this is a box, several boxes will be loaded onto a crate, which are then shipped to the warehouse. So going to the warehouse is a crate filled with many boxes like this, so 9 boxes. Okay, and how do you check whether a crate is rejected or not, well, you pick one box from the crate, let's say it's this box, and you look at the filling of the bottles, and if 2 or more of them are underfilled, then the crate is rejected. Okay, so that's the criteria for a rejection of a crate. You pick a box at random. If 2 or more bottles are underfilled, then the crate is rejected. Okay, so now we can go and answer the question. Define the random variable of interest for the warehouse manager. So what's the warehouse manager interested in? That's written here. It's the probability that a crate shipped to the warehouse will be rejected. Okay, so that should be our random variable. So let's call it x. So x is the probability. So x is the number of bottles that will be underfilled in each box. Right, because the criteria for rejection is that the number of underfilled bottles should be 2 or more. Okay, so that's what he's interested in. How is this random variable distributed? Okay, so we've already calculated the probability that a single bottle is underfilled. That's given in part A of the question here. But now we're looking at 10 bottles, and one more important piece of information in the question is we assume that the filling of the bottles is independent of each other. So in other words, the machine has no memory of what it did on the previous bottle. So the probability of one bottle being underfilled does not affect the future bottles. Okay, so this means to work out the number of underfilled bottles in a box, we're doing 10 independent tests where each test has exactly the same probability, 0.0062, and this is the defining feature of a binomial distribution. Okay, so how is the random variable distributed? X is binomially distributed. Why is it binomially distributed? One more time, because you're doing something 10 times, so that's the number of trials of the same thing, and each time you do the trial, you have the same probability of finding an underfilled bottle. So therefore, this is binomially distributed, and hopefully you know that the binomial distribution is determined by 2 parameters. N is the number of trials, so here that's the number of bottles in a box, 10. And P is the probability that a bottle is underfilled, so here 0.0062. Okay, so that's the answer to part 1. Part 2, determine the probability that a crate will be rejected by the warehouse manager and show you're working. Okay, so let's just go for it. So the probability of rejection is the probability that 2 or more bottles are underfilled. So that's the probability of x being greater than or equal to 2. So you could calculate that, but here it's easier to calculate the opposite. So calculate the probability that a crate is not rejected. So in other words, 1 minus the probability that x is less than 2. Okay, and because x is an integer, this only has 2 possible values, then either x is 0, so all the bottles are okay, or x is equal to 1, so 1 bottle is underfilled. Okay, and then now you can use the formula for the binomial distribution to calculate this probability. This is 1 minus, okay, so x equals 0, so that's 10 choose 0, that's the probability of 0 underfilled bottles times 1 minus p, 10 filled bottles. Okay, and then we have 10 choose 1 for the probability x equals 1, probability of 1 underfilled bottle, and 9 correctly filled bottles. Okay, so now that's basically all we need to work this out. So 10 choose 0 is 1, 10 choose 1 is 10, and p is given here, n is given here. So now you just need a calculator to work this out. And if you do work it out on a calculator, which I did earlier, then you get an answer of 0.00. I'll give it 3 significant figures, 167. Okay, so that means a bit more than 1 in 1,000 boxes is going to be rejected by the warehouse manager. Okay, final part of the question then. To reduce the number of crates rejected by the beauty supply warehouse manager, the manufacturing company is considering adjusting the programming of the filling machine so that the amount of shampoo in each bottle is normally distributed with a mean of 0.56 litres and a standard deviation of 0.03 litres. C. Would you recommend that the manufacturing company use the original programming of the filling machine or the adjusted programming of the filling machine? Provide a statistical justification for your choice. Okay, so obviously the best choice is the one which leads to minimum numbers of rejections, right? So we could go through the whole calculation again with these new values and see which one is better, but we don't actually need to do that, because if you look at the only thing that changes in this calculation in part B is the probability P of a single bottle being underfilled. Okay, so all we need to calculate is what's the probability of a bottle being underfilled with the new programming, and if it's less than this one, 0.0062, then we should use the new program, and if it's more than this, then we should use the old program. Okay, so I'll do the calculation here. So let's compare the old program, well, let's say original program, with the adjusted program. Okay, so the original program was a random variable A, it had a mean of 0.60 and it had a standard deviation of 0.04. So this adjusted program I'll call A prime, and it has a mean of 0.56 and it has a standard deviation of 0.03. Okay, and we want to work out in both programs the probability of a bottle being rejected. So in other words, that the volume is less than 0.50. Okay, so this one we've already done in part A, and it turns out, relating it to a standard normal, that z is less than minus 2.5. Okay, so now we need to do the same for the adjusted program. Okay, so we relate this to a standard normal. Okay, so take the mean away from the value, divide by the standard deviation. Okay, so that gives you 2 or minus 2. The probability that z is less than minus 2. Okay, so by now it should be pretty clear that if you remember what you're calculating, right, this is the normal distribution here. The standard normal distribution, of course, is going through 0. Okay, and you're interested in the probability, this area here, up to z or z prime. And the fact that z is less than z prime means that the probability of z is going to be less than the probability for z prime. So that means the original program is better, right? The original program has a lower probability of underfilling. Okay. But you know, to complete the question, let's just work out the numbers. So here we've already done this. It was 0.0062, and here probability z prime is less than 2. Let's go back to our table. Z prime less than minus 2 is here, 0.0228. Okay, so in fact it's much higher chance of rejection. Okay, so therefore, I would say that the probability of rejection, or probability of underfilling, is greater with the adjusted program and therefore the old program or the original program is better. Okay, and that's the conclusion, right? Would you recommend that the manufacturing company use the original program or the adjusted program? The original program is better, okay, because it has a lower probability of rejection. Okay, and that's completing the solution to this question.